Hello everyone, my name is Thomas Kim. Today is June 20th, 2022. This is my 5th episode for C++ 17, 20, 23 and other parallel technologies. I will discuss deprecated feature in TBB 2020 and removed in oneTBB. Also, I will give you some concrete examples for how to use parallel for and parallel for each. If you haven't read or purchased Intel Threading Building Blocks outfitting C++ for multi-core processor parallelism, this book, I would highly recommend you to purchase one copy of this book. Of course, this book is deprecated, but still, this book is worth reading. I mean by worth reading, some contents of this book is not explained in the book for TBB, this book. Amazon is quite intelligent. It remembers that I purchased this book twice. Last purchase January 22, 2021. This book was published in 2019. But still, some contents of this book are deprecated too. But don't be panicked. Here I am at your service. Now let's see. I would recommend this link. The functionality deprecated in TBB 2020 and removed in oneTBB. If you double click it and scroll down, you can find TBB Atomic deprecated. Now we can use STD Atomic. TBB float tuple deprecated or removed. Instead, we use STD tuple. TBB mutex deprecated. Now we use STD mutex. What does it say to you? It says one thing. All these facts unanimously say that Intel TBB in the past is C++ standard today. In other words, TBB today is C++ standard in the future. In the same context, Intel's SQL today is C++ standard in the future. Now scroll down. If you scroll down, you can find TBB parallel do. TBB parallel do is deprecated. Now TBB parallel for each. Back in our video script, I will give you concrete examples for parallel for each. To follow my current and future sessions, I assume you have watched my previous videos listed here and installed all the necessary tools on your machine. Otherwise, it might be difficult or hard for you to follow my current and future sessions. I provided all the necessary tools and links and documentations. Without further ado, let's get started. Start Visual Studio Code. Open your working folder C++ 17, 20, 23 parallel. Click this button 005 parallel 4. Click this button parallel .cpp. Hit enter. Ctrl V. I will close get started. Include talkplay fun, output, HPP, namespace, talkplay fun, T, types, talkplay fun, types. Please remember namespace, alias, talk, play, fun, types, because we will use this namespace all the time. Talk, play, fun, stream, print, auto, NL, talk, play, fun, NL, flush out to console, auto, NL, simply new line character, new line, void test, parallel for each, void test, parallel for. Please keep this point in mind. We use parallel for each for containers that does not support random access iterators such as std, list, std, set, etc. We use parallel for containers that do not support random access iterators such as std, vector, std, array, etc. std, list 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. std list does not support random access iterators. So I declare int sum 0 or sum up. We capture sum by L-value reference. We captured sum. Okay. Then or it can be value semicolon sum plus equal value. Now TBB parallel for each list begin this list end. We provide sum, then print sum from 1 to 10 equals sum, and control home. I would define one more, and L and copy paste, and L one more carries return. Okay, now we create function main, copy this function, paste it here. We have to use parallel for each for container std list because std list does not support random access iterators. Now open up your command prompt. cd 005 parallel 4. clang plus plus SED C++ 17 parallel CPP LTBB 12. Don't forget it's 12. Or C.exe, hit enter. I would copy this command string and paste it here for those who are unfamiliar with the clang compiler. Now CLS C. So sum from 1, 10 equals 55. I think it's too big. Now let's try with a Microsoft compiler. We use CL, EHSC, SED, C++ 17, parallel, .cpp, TBB, 12.lib, fe, m.exe, hit enter. CLS M. Microsoft compiler also works. Now we move on to Parallel 4. Before we move on to Parallel 4, for those who are unfamiliar with the Microsoft compiler, I would paste it here. In case of GNU, G. Now scroll down. I would change it basic. Copy this name, paste it here. Auto A, talk, play, fun, T, make container. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The type of A is vector. See the pop-up window. The type of A is vector. Now I change it to 5.6. The type of A is now double. Let me try it again. The type of A is vector int. Pay attention to the pop-up window. Now 4.5 float. The type of A is now L. It is actually float. Okay? In this case, double. F. This is actually float. Int sum 0 auto sum up. We capture sum by reference. Also capture A by reference. Const TBB blocked range. This is one-dimensional range. SED size T L value reference R. Watch it very carefully. For auto I equals R, begin I not equal to R end. Don't use like this. Use this. Okay? Plus plus I. Sum plus equal A I. This is lambda, so we need a semicolon. TBB parallel for TBB blocked range. std size t 0. Please understand that blocked range std size t, std size t. This type is determined by this type. Once again, this type is determined by this type. Now, A size returns size t. Okay? Pay attention to return type, size t. This is range. This is range. Okay? Then we provide this task sum up. Print sum from 1 to 10 equals sum and L. Copy this function. Copy. We already pasted. Now we will rebuild LLVM. It works perfectly. Now we will use clang, GNU G++. Not this one, this one. CLS G. It works perfectly. So we have to remember these things. Just so you know, this is equivalent to std vector plot A. We copy this. It is equivalent. These two are equivalent. If you do not specify plot, it does not work. It does not. You have to specify plot explicitly, because 1, 2, 3 are int. f.5 f is plot. You have to specify explicitly. Otherwise, it doesn't work. Okay? So, it is very inconvenient. It is much simpler. We can change the type of A on the fly. It is now double. This is now int. For such purpose, I created this function. This function is defined here. Talk, play, fun, types. Very short, very compact. Now I will close it. Let's move on. Copy, paste. Advanced. Copy this. Paste it here. Semicolon. Now I will delete. Fixed like this. We actually don't need this. We can, okay, I will copy it, paste it here. Now it says auto L value reference R. Okay, this is exactly the same. Now we are calling test parallel advanced, this function. It builds correctly. CLS-M. It builds correctly. G. Now, this is very, very ugly. I really hate this. So, I create a function like this. Template, type name, T, auto, get range, T, constant L value reference, container, return, TBB. Please remember blocked range. You have to remember this class. Blocked range, blocked range, blocked range. Okay, you have to remember this blocked range. The first comes SED size T0. Second comes container size. Now we can use this. Copy. Here I will paste. Instead of doing this, cut, paste. We just pass A. These two are identical. Okay. Now we build again. CLS-M. It works perfectly. GNU also works. The problem is that what if A does not support member size? Once again, what if A does not support member size? To prevent such misfortune, we introduce template, type name T, using void if size available. T, this is type. Okay, this is type. SED enable if T, if this part is supported, then this type function returns type void. So void if size available, we can test like this. You should remember talk play fun type namespace alias is size available. We pass T. Okay, this is not yet perfect. This is not yet perfect. This t should not be constant or R-value reference. So talk-1 t remove CB reference. We have to remove CB reference. This is our final version. Now copy this. We put constraints. Type name paste t. If t supports size member, then this type returns void. So this is valid C++ syntax. This is C++ 17 style template metaprogramming. Now we build again. It works perfectly. So this is C++ 17 style. This is really ugly and tedious. So C++ 20 introduced concept. This is C++ 20 style programming. Ctrl+Shift+P, edit configuration JSON, hit enter. Specify here C++ standard should be at least C++ 20. Okay. Now here we can remove this. Instead here requires. This introduce requires clause. Once again, this introduce requires clause. Requires. This introduce expression. The second require introduce expression. Container size. We test if container has member called size. This is called simple requirement. Okay, this looks still ugly, but let's try it. Now we have to specify C++ 20 CLS concept was introduced in C++ 20, so C++ 17 does not work. It does not work. In the same manner, in C++ 20, it works. CLSC. Now one more. This looks horribly ugly. Very ugly. I would copy this. Now I will enable it. Instead of doing this, I will delete this part. Then here requires. We use T object. I would say obj. Once again, obj size. Simple requirement. This is another syntax. Compare. We build again. Please note that we have to specify C++ 20. Bingo. Finally, This is still ugly. I will copy, comment out, paste. Now we use this concept, this constraints all the time. So we define concept, template, type name D, concept, size, available C. We are defining concept. Concept requires expression. Copy. This is expression. We need semicolon. Very simple. This require I copied from here. Okay. Then by we use size available C. Because we will use this concept all the time. Size available C, we will use this concept all the time in the future. So I'm trying to explain modern C++ as much as possible. We build again. C++ 17 does not work. It should be 20. LLVM. Bingo. We will use clang. Hit enter. CLSC. I reminded you of the C++ concepts in several different ways, starting with all the traditional C++ 17 style constraints. We are using here spin, and I introduced various different ways to explain what is concept, how to use in real application.